Moving on to the next part of the problem in section 3.3, we also studied how the value of a car depreciates after you purchase it. The original value of the car, which would be 0 years after purchase, was $15,000. That's your initial value. And we found that the value decreases by $2,000 per year, $2,000 each year. So they want us to write a formula for the value of the car. That's going to be initial value plus the slope times a variable that represents, in this case, it's going to be number of years. So here they say to write a formula V equals that describes the value of the car in terms of number of years after it was purchased. And they tell us to use the variable t to stand for the time. So what was the initial value of the car? When we bought it, it was worth $15,000. And rather than increasing by $2,000 a year, it decreases. So that's why we're going to have minus. You could have plus negative, but we just usually write it as minus. That's showing a negative slope, minus $2,000 every year. That's my formula for the value of a car. So question number 7, how much was the car worth 6 years after it was purchased? That's going to be $15,000 minus $2,000 when time is equal to 6. So that's going to be 15,000. 2,000 times 6 is 12,000, so minus 12,000. So the value of the car 6 years after purchase is it's worth $3,000. Number 8 says, when was the car worth half of its purchase price? All right, so if it was purchased at $15,000, half the purchase price, 15,000 divided by 2, would be 7,500. They're really asking us, what is T when the value is 7,500? When the value is 7,500, starting point minus $2,000 per year, and we want to get T. So the first thing we want to do is subtract 15,000 from both sides. So we get negative 7,500. Bring down your equals. Bring down your negative 2,000 T, and we want to get T by itself. Right now it's being multiplied by negative 2,000. To undo that, we divide by negative 2,000. And in that case, we're going to get time is 3.75 years. 75, 3/4, that'd be 9 months. 3 years, 9 months. How did I get that? There are 12 months in a year. 9 over 12 is the same as 3 over 4. And here's a smaller version of this graph describing this car value. Does our answer make sense? Let's look at 3, 4. Yep, there it is. Here's about 7,500. And here's 3.75 or 3 3/4 years. Yes, it does make sense. It's pretty close. The height is under 8,000 when the years are looking to be like 3 3/4. How long does it take the car to have no value? All right, so that would be when would the value equal 0? It started at 15,000 and we lose 2,000 per year. So now we want to get t when the value is 0. Once again, we're going to subtract 15,000 from both sides of the equal sign. So we get negative 15,000 equals negative 2,000 times t. And to get t by itself, divide by 2,000. Well, whatever you do to one side of the equal sign, you have to do to the other. And when you do this calculation, you get 7.5, or 7½ years. In 7½ years, a car that was purchased for $15,000, if it loses $2,000 a year in value, in 7½ years, the value will be 0. So if we have value is equal to 15,000 minus 2,000 t, this gives us the value when we know the time. We can write an equation that has, in other words, we want to rewrite this equation for what t equals. Find an equation that provides the number of years since the car was purchased in terms of its value. If we want to find, if we want to rewrite this so that it's t equals. All right, so we're going to subtract 15,000 from both sides and divide both sides by negative 2,000. This is just in general now. The time would be whatever the value is minus 15,000 divided by negative 2,000. That would be the formula I would use. So moving on to, this is a different type of problem now. Just using more formula here. The formula P equals 2L plus 2W is a calculation for the perimeter of a rectangle. P would stand for perimeter, 2 times the length plus 2 times the width. Length and width. So solve this literal equation for width. So if P equals 2L plus 2W, when they say solve for width, they mean they want you to end with W equals. So the first thing I'm going to do is subtract 2L from both sides. P minus 2L is going to equal 2W. Now I want to get W by itself, so I'm going to divide by 2. Perimeter minus 2 times the length, whatever that is, divided by 2. That's going to be the width of the rectangle. So here they want us to look at the relationship between the perimeter, which is the distance around the outside, and the area of a rectangle. Rectangles can have the same perimeter, but much different area. So we're going to use this equation to find the width of this rectangle. All these rectangles have a perimeter of 200. So here, this is going to be 200 minus 2 times 10 divided by 2. So that's going to be 200 minus 20 divided by 2. If the length is 10, the width is going to be 90. Let's find the width when the length is 30. 200 minus 2 times 30 divided by 2. So that's going to be 200 minus 60 over 2. So that's going to be 140 over 2. So that's going to be 70. So we do this calculation plugging in 40, then plugging in 50, then plugging in 80. And we'll get that if the length is 40, the width is 60. If the length is 50, the width is 50. And if the length is 80, the width is 20. I'm going to leave those calculations to you. All right, so area is length times width. So a 10 by 90 rectangle will have an area of 900 square units. A 30 by 70, when you multiply those two, you're going to get 2,100. It's a much bigger area. If you multiply 40 times 60, you're going to get 2,400. If you multiply 50 times 50, you're going to get 2,500 as an area. And if you multiply 80 times 20, you're going to get 1,600 as an area. So although these different rectangles, one would look like this, 1090, and the other would look like that, 5050, they have the same perimeter. But in this case, when length equals width, you have the largest area. In fact, it's much larger. So what conclusions can you draw? There are several, but at least observe that area can change dramatically, even though the perimeter, the distance around the outside is the same. And it appears that the squares will have the largest area.